Hi, everyone. My name is Radu Miklaus, and welcome to the AI-powered linguistics and search webinar. Alongside of me, Robert Lucarini, Senior Software Engineer from LucidWorks, and Nick Ballinger, Solution Engineer at Basis Tech, will be joining into presenting the details. We will touch on three areas. One would be the challenges with languages in search applications. Second one would be how Fusion uses Rosette to address these challenges. And then finally, we'll dive deeper into entity customization. When it comes to search, personalization is one of the main areas of interest, and the process is pretty straightforward, beginning with document ingestion and then launching into search curation, which has multiple steps. First of all, we have to do text interpretation. Then we have to add data enrichment, relevancy tuning, and recommendations. When we're able to complete these steps, we can move into personalization. And through relevancy tuning, we can give the users exactly what they're looking for based on their intent of their queries. And also, once they start the exploratory exercise, we can guide them towards other interesting things by using recommendations very intelligently. So let's talk a little bit about some of the challenges when it comes to text interpretation and data enrichment when it comes to search applications. So the four big areas is language identification, character normalization, increasing the recall without losing precision, and finally enriching data and metadata by extracting entities and using them for smart facets and smart filters. To be able to do this, Fusion and Rosette are partnering to bring best-in-class search and best-in-class linguistics to address these challenges. Let's dive a little bit deeper into essential elements of multilingual search and see how we can boost global search quality with Rosette. One of the first terms and first concepts that we're going to dive into is lemmatization. Lemmatization associates words with the same meaning, like child, children, and it is in many ways an alternative to stemming, which associates words that look alike with different endings, because you have very similar types of words with different format, but same meaning. And it matters quite a bit, especially when we start dealing with European languages. Latin-based languages are a great example of that, where adjective agreement and gender number agreement needs to happen. And also verb conjugations can create multiple word forms, but they're associated with the same single word. And the impact on search is quite heavily increased by increasing recall of relevant results, especially for these types of languages. Tokenization. It divides sentences into words for languages written without spaces between words. And when you think about more complex languages like Chinese, which become very ambiguous at times, the bigram method starts ignoring the meaning and essentially does substring matching of one of the or two characters. And that doesn't really help, especially when a word can mean different things. The impact on search of using great tokenization, especially for complex languages, is greater precision for Chinese, Japanese, Korean, for example. Chinese script conversion covers all records or queries between simplified and traditional Chinese. And this is very advantageous for a search user because they do not have to search twice. They can search all the documents once and then choose the type of the type of character that they would like to look at, either simplified Chinese or traditional Chinese. That way, with one query, one can search on both of them and then decide which one they prefer in terms of scripts. Decompounding, splitting compound nouns. This is very popular for Germanic examples or Germanic language settings, in which it's very common to see multiple nouns used in the same word. And what happens is sometimes when we have multi-noun words like this, we can miss the results where two concepts are separated. One of the examples would be youth and unemployment, cannot potentially be picked up if they're used together in one word, like the example below. So this is very important, especially for German, Dutch, or even Korean search, because Korean has this concept of multi-noun compound words. That therefore we can achieve greater recall. And finally, name entity extraction or name entity recognition. It adds structure to unstructured and multilingual text by automatically pulling out concepts like people, organizations, locations, dates, products, numeric patterns, etc. When you're able to extract this type of metadata, you can add this type of metadata to a smarter way to filter the documents you have, and in many ways will refine your search and remove noise, therefore increasing search relevance. So let's spend a little bit of time to understand how Fusion uses Rosette. In basic Fusion, we have the combination of Solr and the Fusion platform. Solr brings with it the support for multilingual tokenization, and overall, Solr supports 35 languages. However, the support for entities with our Fusion platform, it's based on OpenNLP and only supports 7 entities. And this is where we're seeing great gains by adding Rosette. Rosette will bring 2 main important packages, the base linguistic packages and the entity extractor package. On the base linguistic side, in addition to tokenization, it will bring all the concepts that we talked about earlier, like lemmatization, part-of-speech tagging, Chinese and Japanese reading, decompounding, etc. When it comes to entity extraction, Rosette brings the support of 21 languages, 29 entity types, and over 450 subtypes that can be detected. And that's a huge help in terms of the breadth of use cases that entities can be applied in. Next, I'll pass it over to Robert to talk a little bit about an example of how this personalization and guided exploration can be done with entity extraction. Robert?
Thank you, Radu. In this example, we're going to be demoing the entity extraction functionality of Rosette within Fusion. The actual integration doesn't add any additional complexities to Fusion configuration. You get to use all the out-of-the-box Fusion configurations for creating fields and creating facets. So it's a really seamless way to add extra functionality, to add this functionality within Fusion. So as we'll see in the demo, you'll see this in action.
Hi, this is our demo of the Rosette entity extraction working here on Fusion. This will be a 2-part demo. The first part I'll be going over the Fusion configuration of Rosette, and then I'll show a sample application built using our App Studio UI. So I prepared this application called GDelt. Actually, I'd like to credit Patrick Hoppel for lending me this application. I'd like to start first with the configuration for Rex. So it is based on, it is configured partway through the Solr config. Here we add the processing chain for our Rex entity extractor. So this is pretty much the only update we need to do to the Solr config file. This is where we add the different languages that we want to extract entities from. So in this case, I just have English configured, but you can add additional language packs by adding them, adding the images to your installation, and then creating the different fields as we have here. So here I created a dynamic field. As you can see here, I crawled a bunch of data, and these are the entity fields that have been created as a result of the Rex processing. As we move on, just want to give you a quick review of the pipeline here. To enable the Rex fields, we just added a simple copy field where we copy the contents of the incoming data into our Rex, our basis tech Rex configured field. And then the entity extraction happens automatically. And so with this, I'm showing you the actual crawl data from GDELT. These are the entities that were extracted. You can see there's quite a few of them. So here I can browse the data to see that that the fields are in fact part of the were generated as part of the content that was extracted. Good. So just to review from a high level, in Fusion, we configure the Solr config where we add our update chain, and then we add our dynamic field, which will generate the actual entities from our incoming data. Great. So let's move on to the app. Here I create this. This is actually created by Alex Mollet, so I want to credit him for this helpful UI. Here we see the entities that were pulled from Rex. We can actually drill down to these different facets and see the different articles that are being pulled up and the stuff and the entities that were extracted. So this is quite helpful. It's a nice way to kind of browse all the news that's coming from GDELT. We can also drill in to the actual article, and here in the actual article, we're seeing additional Rex fields that are being pulled. So here we have, in this specific article, we see that these people are mentioned, these organizations are mentioned, and these locations are mentioned. And here are some of the details of what's been, of those facets here. So you can see it's quite useful. Once you have everything indexed and the Rex fields generated, you can do a lot of different things with the data to enrich the user experience. So that concludes the demo. Let me pass it back. Thank you.
Okay, as we saw in the demo, this is a high-level overview of the Fusion ingestion pipeline. Here we see we use the Fusion app configuration stages to create our predefined fields. And then we set up our index pipeline as we do normally, and we point the processor to Rex in our Fusion, in our Solr indexer stage. And then the engine does all the magic and saves the entities directly into our index without any further configurations. Just want to highlight in our Fusion 5 architecture that since Rosette is embedded within Solr, this will have no additional impact to your infrastructure. There's no additional pods or services that need to be created to support Rosette.
Cool. So what I'm going to go ahead and do now is I'm going to take a little bit of a deeper dive into the entity extraction portion that we discussed up to this point. In this little section of the presentation, I'm going to give you an overview of how entity extraction is actually performed from a more mechanical level. And then we're going to spend a little bit of time talking about all the different ways entity extraction can be customized. And you'll be seeing that in action during the demonstration in just a little bit. So right off the gate, what we're going to dive into here is just a high-level overview of what the entity extraction tool is capable of and what different elements make up the entity extraction workflow. So at a high level, there's 5 different steps that make up entity extraction. There is the beginning step, which is where the base linguistic suite is run to determine where tokenization should occur, where sentences begin and end, and so on. Then there's the actual extraction bit, which I'm going to hone in on in a moment. And then there is essentially 2 cleanup steps before the results of the extraction process are returned to the end user. Now, the most interesting part of this whole process is the actual extraction bit. And what you're seeing on screen is a breakdown of the 3 different techniques we utilize to make sure that when entities are extracted, we're not leaving anything behind, so to speak, and we're as accurate as we can possibly be. Now, starting on the left side here, you can see we're discussing our statistical extractor, and that is a machine learned model. In some cases, it's actually a deep learned model or an AI, and that is designed to find entities in a given body of text the same way you and I would try to figure out what a word we've never seen before means. It's going to examine all of the context surrounding that word, and it's going to look back upon all of the sentences it's seen up to this point and make a judgment call. This makes it extraordinarily flexible because it can find entities that may have never been seen before, ever, because it's going to use the surrounding context. That said, we're not all in on this approach. There are some situations where simpler is better, and the old ways happen to be the best ways. And so accompanying the statistical-based approach, we also have a list and a pattern-based approach. That's more or less exactly what it sounds like. These are user configurable ways where you can quickly add new patterns to find or new words to check off a list. And we're going to be diving into that in just a second. So as promised, one of the focuses of this section isn't just how entity extraction works, but also what you can do as an end user to ensure that it is doing the best possible job it can, given your text and given your use case. Now, when I talk about customizing our entity extractor, I like to break it up into 2 big categories: configuration and customization. Configuration is designed to be quick and easy. You're essentially going to be leveraging the knobs and the levers that we built into the tool to go in there and make changes. This is actually mostly file manipulation, which means that it doesn't require a large amount of technical skill or technical ability to get in and affect the way matches are made. So that's A, configuration, quick and easy changes. B is customization. And customization is where it begins to get really fun because you can have drastic impact on how extraction is performed. And that's because in the realm of customization, you're actually able to manipulate the model itself. So that's kind of a high-level overview of these 2 options. What I'm going to do now is I'm going to dive into specific examples of what you can change when you're configuring the tool, as well as what you can change when you're customizing the tool. Now, as mentioned before, when you're configuring the tool, most of your efforts are going to be spent customizing our gazetteer or our list-based extractor, as well as our regex statements or our pattern-based extractor. Now, the list-based extractor is an excellent choice when you're trying to identify a new entity, but it isn't either sufficiently complex enough that it requires you to train an entirely new model, or alternatively, when it is a defined set. For instance, it does not make a lot of sense to train a custom model to identify all of the world's car brands because you could very easily populate a list with them and you would get that job done a lot more quickly. Regex is slightly different. Regex or pattern-based matching is excellent when we know the format a specific entity would take, but we can't exactly predict what it'll look like. great example of this is a phone number. We all know what a phone number looks like, but instead of populating a list of every single possible phone number in the world, you can simply create a pattern. And as soon as our entity extractor sees something that fits that pattern, it is going to pull that out and it's going to tag it as whatever entity type you desire. Again, the overarching theme here is that both the creation of lists as well as the creations of rules is something you can do quickly and easily. It's an excellent short-term solution and potentially even a long-term solution, depending upon what type of problem you're trying to solve. Okay, that's interesting. What if we start getting into actual customization of the tool itself? Well, as I mentioned before, one of the major aspects of customization is training the model itself. And this is useful for two primary use cases. The first use case is when you're trying to find a new kind of entity, but both a list-based approach and a pattern-based approach are insufficient for what you're trying to do. In that case, yes, you can absolutely go in and you can train the model to identify that new type of entity based on context, which is an enormously powerful thing. So that's one use case. The other use case would be if you're not actually desiring any additional entity types, maybe the default ones work just fine. However, maybe they're not being found with enough regularity or enough accuracy with the specific type of text you're analyzing. Maybe you're working with a medical document, or you exclusively are trying to run entity extraction on contracts, where language is used a little bit differently than it is in the day-to-day. By training the model to recognize that style of text better, you can improve accuracy across the board without actually needing to create new entity types. Then, lastly, there's the realm of custom processors, and I've left this for last because it's perhaps the most open-ended option available to you. Custom processors essentially let you insert your own code into this entity extraction pipeline, and this can be used to accomplish all kinds of stuff. The example I like to use here is something like standardization of entities, right? Let's say that you are analyzing a bunch of different documents that all have coordinates written down within them, and you're able to find them. Maybe you've created some regex statements, but they're all in different formats. Wouldn't it be nice if when you are actually storing these documents, the metadata that they are being tagged with uses a standard format? Well, you can actually make that happen with a custom processor. You could write a bit of code that takes a look at all the coordinates found within a given document and then transforms them before stamping them down as metadata. That's only one example. Again, it's really only limited by your imagination and what you can do with a bit of code.
Okay, so what we're going to go ahead and do now is we're going to take a look at how the entity extraction toolkit I discussed earlier performs out of the box. And we're also going to be paying attention to all the different ways we can go in and we can start manipulating how the tool functions and all the different ways we can enhance its default extraction behavior. Now, for this little demonstration here, we are going to be using a personally identifiable information-based use case. And we're going to be imagining that we want to use entity extraction to empower us and increase our ability to go in and identify PII within a given document. Now, for the purposes of this little demonstration, we are going to be taking a look at this document here. The idea here is that this is a document I created that is absolutely flooded with different bits of PII within it. Everything from passport numbers all the way through to driver's license numbers. There's many different options available here. Now, if we were using a human analyst for this task, this is essentially where it would begin and where it would end, because you would have that analyst go in here, read through this, and either highlight or otherwise call out all the bits of text or all the entities that are problematic and maybe exposing information that ought not to be exposed. However, that's not what we're going to be doing today. Today, we're going to be trying to use entity extraction as a method for solving this problem. And so we're going to begin by using the entity extraction toolkit we've been discussing up to this point to see all of the different things it's able to find out of the box with no additional work, no additional configuration at all. So when we task our toolkit to go in and analyze this document, what it does is it comes back with something like this, and it says, all right, I was able to find some entities. And just to explain what you're seeing on screen, everything that I've gone in and I've highlighted in yellow is an entity that has been found. So the email addresses at the top, the individual names, the organizations and the companies, so on and so forth. But then at the bottom, I've also broken it out in this nice little table, just so that it's a bit easier for us to see exactly what it is we found within this specific bit of text. Now, out of the box, again, with no changes at all, we're actually getting really good results here. You can see that we were able to go in and find things like email addresses, the names of different locations, and perhaps most important for our PII-focused use case is that we were able to go in and we were able to locate both a credit card number as well as a social security number, which you're actually seeing here and here. This is very, very valuable stuff, and we've already saved a ton of time over having a human analyst go in and do this, because our tool is able to locate these things in a matter of seconds, actually less than a second if we're keeping score. Now, that's awesome, but it hasn't found absolutely everything of interest to us, and that's simply the reality of using a machine learned process or a statistical model in your tooling, is that it's never going to be 100% accurate. And if we go in here and we take a look at what it missed, we can see that there are a few choice entities that have been dropped. So when we go ahead and we take a look at what hasn't been found and we highlight it, we see something like this. So again, what you're seeing highlighted now is all the different entities that we were not able to find before. Now, there's essentially two broad categories of entities we've missed here. A bunch of them are numeric in nature, or predominantly numeric, which are things like this passport number or this driver's license number. And then a couple of them are actually purely text-based, something like Smart Shield, which is presumably a product, and GrayGuard, which is presumably an organization. Now, that's fascinating, and it's unfortunate that we've missed these, but again, that's always going to be the case. Any model or any approach that's based on a statistical approach or is based on a machine learning approach is going to have blind spots. So it's most important when you're setting up an entity extraction pipeline or you're creating an entity extraction toolkit is to be aware of that and make sure that you're making it as easy as possible for people to go in and make changes to cover those blind spots. And that's actually exactly what we've made available in our toolkit. What we're going to look at now, we're actually going to switch screens really briefly, and we're going to take a look at the types of changes we need to make to the tool to ensure that moving forward, it's always able to find entities just like these. And we're actually going to begin by taking a look at these numeric-based entities. So again, the IP address and the passport number and so forth. Now, finding those entities is going to take the form of regex statements, which is pattern-based matching that I discussed earlier in my slide presentation. Now, what you're seeing on screen now is a bit of XML. This is not pure code, it's not anything like that. And in fact, the operative bit of this file, the part that's actually empowering our tool with additional logic, is just these two lines right here. And all it's saying is, hey, whenever you find an entity or a bit of text within a document that matches a specific pattern, I want you to pull it out and I want you to tag it and say, hey, that's a US passport number. Now, specifically US passport numbers always follow the same pattern. They're 6 to 9 digits and they've got no spaces separating them, which is what we're looking for in documents when we say we want to find a US passport number. But that's not the only entity that was of interest to us, right? We also had that IP address and we had that driver's license. And so we've created similar rules for those types of numerics as well. In this case, we're specifically hunting down Massachusetts driver's licenses, which start with an S and then are followed by 9 digits, and then an IPv4 address, which is 4 groups of up to 3 numbers each separated by the dot. Excellent. So we've gone in and in just 6 total lines, we've now created a process by which we can find 3 totally new types of entities. No matter which form or whichever numbers, for instance, comprise the IP address, as long as they follow this pattern, we're going to find them no problem. But if you'll recall, there's actually more we missed here, right? We also missed Smart Shield and we missed GrayGuard. Now, there's 2 approaches we could take to remediating this problem. The first one is to actually go in and retrain the model itself, which is something you absolutely can do. However, that may be overkill given what we've seen today, we're only really having issue with these two specific entities. We know they're of importance to us, so it would actually be altogether easier to simply go in and add them to a list or a gazetteer that says, hey, whenever you, entity extractor, encounter either of these bits of text within a document you're analyzing, I want you to pull them out and I want you to tag them as entities of a type of my choosing. And that looks a little bit like this. And this is actually even more straightforward than creating that rules-based approach we just touched on for things like the driver's license, because all it entails is 4 bits of text of plain English. 1 line to denote the type of entity you want it to be tagged as, and then a 2nd line to tell you exactly what it should be searching for. So all these 2 lines are saying is whenever you find Smart Shield, pull it out and tag it as a product. And the same thing holds true for GrayGuard. Whenever you see that, pull it out and tag it as an organization. Having it be this easy, of simply navigating into the file system and making these quick changes at these specific files, means that not only can you overcome obstacles really, really quickly when time is of the essence, but it also means that if you're working with relatively small scale problems, where maybe it works fine 99% of the time, but you're just struggling on specific entities, you've got an easy way to fix that problem without having to embark on the longer process of actually training the model itself. Okay, so let's say we went in here and we made all these different changes, which would take between a half hour to an hour, depending upon how versed you are with regex. Let's see what we get once we've made these changes and then tell our tool to analyze that bit of text again. Okay, so when you rerun it, the output is actually going to look something like this. And before we dive into the specifics, let's just talk about the colors we're seeing on screen here. So if you'll recall, the idea behind this exercise is that we want to go into these documents and we want to locate bits of personally identifiable information. And so the colors I've chosen here are essentially an attempt to divide our entities along those lines. All the entities highlighted in green belong to one category, the category of entities that are likely not containing any kind of personally identifiable information. On the other hand, the entities highlighted in red almost certainly are, containing personal information of some type. Okay, so now that we've got that out of the way, let's actually take a look at this. And the most immediately noticeable thing is that we are now successfully finding all of the different entities of interest here. We're now able to find that passport number and that IPv4 address, as you see there. This is providing a very important bit of acceleration into our process. If you recall, we began this with the idea that if a human analyst was tasked with doing this, they'd have to go in and find these things manually. Now we're at a point where we took the excellent out-of-the-box performance that was finding nearly everything we needed, and with a few quick changes, we were able to go in and we were able to empower it to find these additional bits of detail that we were otherwise missing.
Thank you so much, Nick. So as the takeaways for the webinar, robust language and entity support technology is essential for text interpretation and enrichment and hence personalization when it comes to search. Fusion and Rosette technology stacks are now integrated to provide this great experience that combines AI-powered search and AI-powered linguistics. If you'd like to find out more, please visit the Basis Technology booth at the upcoming conference Activate. Thank you so much.